Hey, welcome to The Explainer. Today, we're going to talk about something that's quietly reshaping our entire world, one little decision at a time. We're talking about machine learning.
So, have you ever stopped and wondered about your email? I mean, how does it just know what's junk and what's important? It feels almost psychic, right? Is there some tiny person living inside your computer meticulously sorting all your mail?
Well, as cool as that would be, the answer isn't a tiny person and it isn't magic. It's a really powerful corner of artificial intelligence called machine learning. And today, we're going to pull back the curtain and show you exactly how the trick is done. All right, let's get right into it. What is machine learning? We hear this term thrown around all the time, but let's actually break down what it really means.
Okay, so at its very heart, it's all about one thing, teaching computers to learn from experience, pretty much just like we do. Instead of a programmer trying to write a giant list of rules for every possible scenario, we give the machine a ton of data and let it figure out the patterns for itself.
And this is a huge shift in how we think about software. I mean, the old way, traditional programming, was all about a human writing every single rule. If an email contains this word, then it's spam. With machine learning, you don't do that. You just show the computer thousands of examples of what spam looks like and what it doesn't, and it literally learns the rules on its own.
And it turns out, just like people, machines have a few different ways of learning. Let's break down the three main styles. The most common way is called supervised learning. The best way to think about this is like studying for a test when you already have the answer key. You've got flashcards, and the correct answer is already on the back. That data is labeled, which is just a fancy way of saying we've given the machine the right answers to learn from. Remember our spam filter? That's a perfect example. It was trained on millions of emails that were already labeled spam or not spam. It's the exact same idea that lets a computer look at a photo and know if it's a cat or a dog, or even helps doctors spot diseases in medical scans. But what happens when you don't have an answer key? Well, that brings us to unsupervised learning. Imagine someone just dumps a giant box of old, mixed-up family photos in front of you and says, organize these. You don't have any labels or instructions, so you'd start finding patterns on your own, right? Grouping by event or by who's in the photos. That is exactly what an unsupervised algorithm does. And this is incredibly powerful because it helps us find patterns we didn't even know to look for. Companies use it to find different groups or segments of their customers. Banks use it to spot credit card fraud that just looks weird compared to your normal spending. And news websites use it to group all the articles about the same breaking story together automatically. So when you boil it all down, the biggest difference is the data. Supervised learning needs that answer key. It needs the labels. Unsupervised learning just dives headfirst into messy, unlabeled data and finds the structure all by itself. The third major type is called reinforcement learning, and this one is all about learning by trial and error. Honestly, the best analogy is training a puppy. When it does the right thing, like sitting, it gets a reward, a treat. When it does the wrong thing, there's a penalty, no treat. And over millions of tries, the puppy, or in this case, the algorithm, learns which actions lead to the most rewards. This is the amazing tech that lets robots learn to navigate a maze or allows an AI to master incredibly complex games like chess and Go, even beating the best human players on the planet. So we get the different ways machines can learn. But how does one of these systems actually get built from scratch? Well, it all comes down to a core workflow, a kind of recipe. The process pretty much always follows 4 key steps. It all starts with data, and you usually need tons of it. Then, from that mountain of data, you have to pick out the important signals or features. After that comes the fun part, training the model, which is where the real learning happens. But you're not done yet. You have to test it on brand new data to see if it actually works in the real world. And the thing you get at the end of that whole process is called a model. You can just think of it as the digital brain. It's a complex mathematical thingy that has basically stored all the patterns it learned from the data, and now it's ready to make predictions. But making that brain is a very tricky balancing act. If your model studies the training data too closely, it's called overfitting. It's like it just memorized the answers for a test instead of actually learning the subject. It does great on the test, but can't solve any new problems. On the flip side, if the model is too simple, it's underfitting. It just fails to learn the patterns at all. The real goal is to find that perfect sweet spot right in the middle. Now, to build these models and find that sweet spot, data scientists use a wide variety of what are called algorithms. You can think of these as different recipes or specialized tools in a toolbox,
each one suited for a specific kind of problem.
Now, we won't dive into the crazy math here, but you'll hear these names get thrown around. Some, like linear regression, are pretty simple and great for predicting something like a house price. Others, like neural networks, are way more complex. They're the engines behind the most advanced AI we see today. Each one is just a different tool for a different job.
So why does any of this matter to you? Because machine learning isn't some far-off futuristic technology anymore. It is already here, working behind the scenes, making your world smarter every single day. It is everywhere. It's powering medical breakthroughs, it's protecting your bank account from fraud, and it's recommending your next favorite movie. It's the engine inside self-driving cars and the shield that protects you from cybersecurity threats. It's the invisible force that's just everywhere.
So look, if you take away just one thing today, let it be this. We are no longer just telling computers what to do. We are now building systems that can learn, adapt, and improve, all on their own.
And that really leaves us with a fascinating and kind of huge final question. Now that we've given machines this incredible ability to learn, what's the next big problem we should teach them to solve? The possibilities are incredible, and so are the responsibilities. It's definitely something to think about.